The picture I had in my head was the ladder. Do you remember the ladder, right? So we're at the top of the ladder right now. Here's IN, and I can see it in terms of what's the next step down, IN minus 1, right? And if I went down another step, I could see IN minus 2, and so on. Eventually, I should get to some I, maybe I1 or I0, which I can actually just integrate, rather than some awful mess like this, okay? So I start at the top. What's it equal to? Well, it's this of this, right? That's me looking at the next ladder down, okay? The next rung of the ladder, I should say. So when I put in n minus 1, everywhere I see n, what happens? Numerator should be n minus 1. This denominator, that n minus 1, that minus 1 will cancel with plus 1, right? So you get m plus n, yes? And then you can see the next rung down, okay? Now, we've got to establish a pattern here. Generally, 3 steps is enough for a pattern, yeah? Because otherwise, if I give you 2 steps, you don't know whether the next number is 3 or whether it's 4. Could be an AP or a GP, right? So you need that 3rd step to establish it. And people were sort of trying to be quicker, I think, and we're running out of time. But you have to have that number of steps. So you've got n minus 2 here, m plus n minus 1, and then you've got the next rung down. Okay, there you go. That's enough steps. Pattern's established. I can see what's happening to the numerator and the denominator. Cool. I'm going to skip to, now where should I go? Where's a safe value to go to? I think probably your minimum value is 2, but I think a safer value is 3, because again, I'm looking for a set of 3, and I0 might be something which breaks the pattern. Okay, it's going to be an integral that I'll need to evaluate, right? So here's what I'm going to do. I3, what happens in here? Well, it's this, but with 3's in it, right? So this is what you should get. You've got n on top, then you've got m plus n plus 1, that's 4, yep. And then I can see the next rung down. Next one, okay. These are all reducing by 1, aren't they, right? So you've got 2 on m plus 3, and then I see the next rung down, okay. So my pattern is establishing here. Okay, now, at this point, you've got 2 signals that you know what to do here, right? The first signal is the pattern cannot continue. It doesn't work for I0, right? Because if you put 0 out here, it's just everything 0, okay? Secondly, this, well, think about what I0 would be. What's our definition for IN? It's all this stuff, right? So I can my original one, I can evaluate that when n is 0, right? So this is what you get. I0 is equal to, and you say the integral, not using the recurrence relation anymore, okay? So you've got x to the m out the front, and there's your n, right there. Okay. So that's good, that's just x to the m. So what do we get here? That's going to be m plus 1 on m plus 1 from 0 to 1. Yep. So what do I get? That'll be 1 on n plus 1 minus 0. So there you go. Right there, that's I0. Okay. So now I've got all the rungs on the ladder. Now, and only now, can I put it together. Some people, what they did was, they said, okay, here's IN, and then they tried to build the recurrence in here, right? But invariably they forgot these guys. You need these guys. They're the end of the ladder, right? You haven't established where the product that I'm about to write, you haven't established where it ends unless you've done these, okay? So now we can put the whole thing together, right? Here's what I've got. All of these numerators, all multiplied, right? So on the top, I'm gonna have n minus 1, n minus 2. Now I can say dot, 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 which corresponds exactly to this dot, 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 right? Times 3 times 2 times 1. There you go, all the way up to there, okay? And then I've got another 1, don't I, for this last term. So I multiply by 1 again, okay? Now, what's on the denominator? Where do I start? I start there. I go down. I go down again, and now, because I've established a pattern, I can say dot, dot, dot. Okay, where do I finish? Well, it just so happens that I can see this pattern here actually still is preserved, right? So to get the last 3 steps, I can just say this. 3, 2, 1. There you go. Okay, so what do you do with that? How can I use factorial notation and it's not a hard one. To simplify this, well, numerator first. That's an easy one, right? You start from n, you go all the way to 1. So what's that? N factorial. Cool. Okay, that's easy. But when you have a look at the denominator, he starts at this number and he starts going down like a regular factorial does, but it doesn't go all the way down to the end. It doesn't go all the way to 1, right? So it's like this, but it's missing some terms. How many terms is it missing, right? Well, just in case, I think some of you can see it, but I think the abstract numbers make it a bit harder to see. If, for example, I gave you this, right? Which would be a typical sort of thing from arrangements, okay? You can see this starts off like 10 factorial, okay? But it's missing, what is it missing? Here it'd be 6 times 5 times 4 times 3 times 2 times 1. That was what would complete the 10 factorial. But I know what that is. I have a way of writing that. 6 times 4 times 3 times 2 times 1. That's 6 factorial, right? And it's not there, it's missing. So I divide by that, right? So in exactly the same way, I look and I see how many terms are missing off the end of my m plus 1 factorial, and the answer is m factorial is missing, okay? Because that's this term off the end here, right? But that's division on the denominator, so all you really need to say was that. To put it on the right side. And that's all. That's it. That's as simple as it gets. You can't really do anything else apart from that, okay? Any questions? I know, Romain, you particularly wanted to see this. Was there, which step was the crucial one for you? Which was the hardest part?
I didn't do this I-zero, but it kind of fell from
Ah, I see, okay. Yeah, you would have, what would you have done? Though, you would have gotten, you could still do n factorial on top, couldn't you?
Yeah.
Right? But then, yeah, okay.
I already knew it was n plus 1, but I didn't actually show it.
Yeah, okay, yeah. Yeah, this step here, well, I think there's kind of 3 pieces to this, right? Constructing the ladder, if you like. You've got the top of the ladder, then you've got the bottom of the ladder, and then you've got the, well, if you like, you'd call that the ground, which has to be done in a different way. You've got to do an actual integral, right? But then once you've done that, you can put it all together. There's your product, and it simplifies out quite nicely. Okay. All right. Excuse me. Thank you, everyone. You've done well. Now, I need you to have a look through your paper now that we've gone through all the questions and make sure. Oh, I didn't say where I put those marks. Sorry, I should do that. Let's see, here, for integration by parts. There was only 1 mark on this first part, right? 1 mark? Yeah. So the 1 mark was really just here, choosing an appropriate u and dv and putting them in. It's not enough to have an appropriate u and dv just on their own. You've got to actually put them into integration by parts. So there's 1 mark there. Part 2, the 2 marks, where did they go? Okay. This step, right there. This manipulation, that's hard. This here is nothing dramatic. You don't need to be able to see anything particular, but this is tricky, okay? There's 1. The other step was, the other mark was here. Evaluating the integrals, right? Or rather, putting it in terms of your capital I's, right? So that you can get rid of your integral terms. So there's 2 marks there. Last bit. Okay. The first mark was for these parts of the ladder, right? So you need the top of the ladder, the bottom of the ladder. If you only got the top, you lose that whole mark. You don't get half a mark. That's the way it works in the HSC, right? 1 mark there. 1 mark for evaluating I naught. And then the final mark was for, I think if you got up to here, even if you didn't put the m factorial in the right spot, if you identified all of the factorials, then I thought that was enough. And I gave you the 3rd mark,